Hi everyone, I'm Tally, a PhD student in Regina Barzolet's group, and today I'm going to show you how to use NVIDIA's Boltz-2 service. Boltz-2 is a state-of-the-art biomolecular structure prediction model offering fast, high-accuracy structure predictions for complexes involving protein, DNA, RNA, and small molecules. Boltz-2 is especially suited for predicting binding affinity, but since that feature is not currently available on NVIDIA's site, we will focus on structure prediction. So to start, we are going to navigate to build.nvidia.com/mit/boltz2, and we'll see this web interface for working with the Boltz-2 model. And if you click here, you can see view examples, and you can see a few different examples of biomolecular complexes that are provided. So we're going to start by talking through this human KRAS protein with covalent ligand example, and then I will show you how would you enter an example of your own. Just to talk through it, we can see that this complex has three different components. It has the protein chain A, which is the sequence of the KRAS protein. And then it has a ligand component, which is specified by the CCD code or the chemical component dictionary identifier of U4U. And then it also has a bond, which specifies that residue 12, the sulfur atom of residue 12, is bonded to a carbon atom on the ligand. So this input produces this output on the right. So now I'm going to click clear all, remove all, and now I have no more components and I'm going to enter them myself. So I'm going to just manually enter the streptococcal protein with pocket example. So to start, we're going to add the protein for the streptococcal protein, and I'm going to copy and paste the protein sequence here. If I had my own MSA, I could provide it here, but I don't. Then I'm going to add a ligand, and I'm going to add it using the SMILES string. So I selected ligand from the dropdown, and then I pressed this new button. So now I'm going to copy and paste the SMILES string. And now I'm going to add a pocket. So I'm basically telling Boltz where on the streptococcal protein do I expect this ligand to bind, and this ligand is ATP. So I'm adding a pocket, and I'm going to say that the ligand, ATP, is binding the protein A, and it's in contact at residues 12, 15, and 18. And once I've entered all of that, I'm going to click run and wait for a bit. Cool. And now I have the structure, and you can look at it here. I'm going to just go, I'm going to show what it would look like if I wanted to fold a MHC protein along with a peptide. So, and I'm going to add a protein, and I'm going to put in the HLA AO2, and then I'm going to click protein again and add the sequence for my peptide, and then I'm going to click run. And now I see that I have my MHC protein with my peptide. That's a short tutorial on how to use Boltz-2 in the web application. And you can also take a look, and there's examples of how to use Boltz-2 in a Python script, a shell, and Node using the NVIDIA service. Thanks for watching.